Also, the authors shared their full framework on GitHub, and it's pretty comprehensive. You'll find the complete codebase there, including training and evaluation scripts for various models. It's a full-stack system designed to scale reinforcement learning to those hour-long videos we just talked about. Okay, so this first figure really shows how efficient that new training infrastructure is. The authors developed what they call multimodal reinforcement sequence parallelism, or Mr. SP. This is a special system designed to split the heavy workload of processing long videos across multiple computer processors, or GPUs. These charts compare training times with and without this new system. As the videos get longer, the standard method gets much slower and eventually crashes from an out-of-memory error. But their multimodal reinforcement sequence parallelism system delivers up to a 2.1 times speedup and avoids those memory crashes entirely. So, what kind of tasks can this new, faster system actually handle? This next figure gives us a great look at the model's reasoning abilities. We see examples from a football match, a poker game, and even a spatial tracking puzzle. What's really cool is how the model shows its work using a technique called chain of thought. This is where the model literally writes out its step-by-step reasoning, starting with a think token before giving the final answer. For the spatial puzzle, it actually gets better as it sees more video frames, showing it really benefits from that long-form context. So to get that kind of advanced reasoning, the model needs really good training data. And these charts break down the new dataset the authors built for this, called LongVideo-Reason. The first chart shows a really diverse mix of video types, from sports and gaming to travel and entertainment. Building on that, the second chart shows the questions are designed to teach specific skills, focusing heavily on temporal and goal and purpose reasoning, which is crucial for understanding long, complex events. Finally, the last chart shows their new data makes up a huge chunk of the total training material. Alright, so with that specialized data set, how do they actually create the final model? This diagram lays out their clever two-stage training pipeline. Stage 1 is a reasoning warm-up. Here, they use supervised fine-tuning, which is a process where the model learns by studying examples of correct reasoning, much like a student reviewing solved problems. Then, for Stage 2, reasoning scaling, they switch to reinforcement learning. This is more of a trial and error approach, where the model gets rewards for good answers, helping to scale its reasoning skills on more challenging videos. And this table really shows the payoff from that entire pipeline. It details the performance of the final model, LongVILA-R1 on their new benchmark. We can see it going head-to-head with big names like GPT-4o and Gemini 1.5 Pro, across those reasoning skills we saw earlier, like temporal and spatial. And look at that. It gets the highest overall score, even tying with Gemini on goal reasoning and outperforming everyone on spatial reasoning. This really proves how effective that specialized training is. Building on that benchmark performance, this chart really highlights how the model achieves those scores, especially with longer videos. We're looking at accuracy plotted against the number of video frames. The red line represents the model with that specialized reasoning training, and you can see its accuracy climb steadily as it gets more context from the video. In contrast, the baseline model without that reasoning training, shown in black, actually peaks and then gets worse. This really proves the training helps the model effectively use that extended context, rather than getting overwhelmed by it. So to wrap things up, this research really shows that it's not just about feeding a model more data, but feeding it the right kind of data and training it in a smart way. The key takeaway is that by combining a specialized reasoning dataset with a two-stage training pipeline, first learning from examples, then improving through trial and error with reinforcement learning, you can achieve state-of-the-art results. And they made it all practical with a new training system that dramatically speeds things up. That's all for this week's AI Research Roundup. Thanks for tuning in.